Hello and welcome to our broadcast titled Redis for Fast Data Ingest. It's my pleasure to introduce today's presenter, Roshan Kumar, Product Management at Redis Labs. Real-time streaming data ingest is a common requirement for most big data use cases. While designing a solution in production, it is essential that the performance of the software stack matches with the physical layer. Not doing so often leads to massive data backlog and losing critical data. During this broadcast, you will learn about the challenges in designing a fast data ingest solution and how Redis, with its abilities to support millions of writes per second with sub-millisecond latency, pub/sub capabilities, and data structures such as lists and sorted sets, enables you to address your needs with very little effort. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. We will be taking questions throughout the broadcast. There is a question and answer feature in the control panel you can use to post questions. All questions will be answered in the order that they are received. Thank you for joining us today, and at this time, I'll turn the broadcast over to Roshan. Roshan, take it away.
Thanks, Sharon. Hi, everybody. Good morning or good evening, wherever you are. Today, I'm covering a very interesting topic, fast data ingest. And the agenda for today is I'll give a very brief overview of what fast data ingest is, and just to set a context. And then I'll talk about Redis for fast data ingest and some of the data structures that you have in Redis, some of the features such as pub/sub, and also sorted sets and so on. But most of my presentation, or the most interesting part of my presentation rather, will be the demo. I'll show you how to use pub/sub, lists, and sorted sets in your programs, and also go through some of the use cases. I'll show you an example of how to stream data, how to get data, and use data for fast data ingest in these three scenarios. And finally, we'll talk about Redis Enterprise and see how you can scale with Redis Flash and some of the other cool features with Redis Enterprise, such as failover for pub/sub and so on. So I'll cover briefly that towards the end. And if you have any questions, feel free to ask them, but I will take the questions towards the end. I hope it's okay with everybody because I have quite a bit to cover, especially the demo. All right, so fast data ingest scenarios. I don't want to go deep into this, but I'm sure everybody is familiar. We are getting data from so many places, and sometimes they arrive in bursts. And the challenge here with fast data ingest is you need a system that can collect all data at whatever speed they arrive. And also there is no uniformity or there is no standard followed in the data format. So you may get data in many different formats. So you need to collect all the data and push it to some other destination. So it could be IoT or network traffic inspection, or it could be social media analysis. There are many scenarios. We can go on and on. There are many scenarios where you collect a lot of data in burst, and you push all the data to some other destination for further analysis or for cold storage or whatever. Okay. Now, challenges. I already touched upon this. It is the fast pace of arrival, and it is unpredictability. Now, you cannot predict at what pace the data arrives. Sometimes they come in bursts, and you need a very fast system that can write all the data. And you need to support data arriving from many sources. And also another big challenge is as the data arrives, since there is no standard format, you need to filter the data, and sometimes you need to transform the data the way the destination requires and so on. And you should do all this in real time. And if you don't do that in real time, and if you don't do this at a faster pace than the arrival, than the pace of arrival, then you will end up having a backlog of data, which may again lead to data loss, or you may not be able to achieve what you want to in real time. Right? Now, what are the requirements for a fast data ingest solution? First of all, there is physical infrastructure, and that's beyond the scope of this discussion. So here I'm assuming you already have a good physical infrastructure to record all the data. But what's part of this discussion is to have the software stack. We'll talk about the software stack, and especially Redis as a data collection data store. Now, what the software stack has to do here is it has to filter data, collect all data, filter data, aggregate them or transform them, and distribute all of them to the destination in real time with sub-millisecond latency. So this is the requirement. Right? Now let's talk about Redis for a second. In the interest of those who are new to Redis, Redis is an open source in-memory database platform. It's an extremely popular database, and it's known for very high performance, something like millions of writes per second, with very low latency and with least resources. And about Redis Labs, now Redis Labs is the home of Redis. Redis Labs sponsors the open source Redis project. And also Redis Labs offers Redis Enterprise technology. We will talk about Redis Enterprise a bit towards the end of this webinar. And Redis Enterprise offers high availability and many other cool features, especially for production deployment of open source Redis. Okay. Now, why is Redis so popular, and why is Redis so good for fast data ingest? First of all, the performance. Now, what you see on the screen is a chart. It's a very interesting chart. I'll give a small background to this. Google wanted to show that Google Cloud Platform can support 1 million writes per second. So a few years ago, they published a blog where they showed that you could do this using Cassandra. And Google showed that you could do 1 million writes using Cassandra, but you required 300 servers to do this. Couchbase took this opportunity and they published a paper on the same note, and they demonstrated that you could do the same, you could achieve same 1 million writes per second with the same packet size, but only with 50 servers, right? That's cool. Redis Enterprise, we took advantage of that, and we also did the work in parallel, and we showed that we could do 1 million writes per second with the same data packet length and with all the same requirements, but with only 2 servers. And that's our story. So Redis is extremely fast, it's lightweight, and it performs millions of writes per second with very low latency, sub-millisecond latency, and most of all with the fewest resources. And also, Redis has some nice data structures. Many of you may be familiar with these data structures, and they come in very handy. I'll give an example. Suppose you want to dedupe all the messages coming in. Set data structure comes in so handy. You can just add all your messages to set data structure, and set ensures that you have a unique object inside the data structure. So you automatically dedupe all the messages as messages come in. So that's just an example. But today I'll show how you can use lists and sorted sets for fast data ingest. And also, Redis has pub/sub capability. It is a message broker, as many of you may know. So you can publish messages to a channel, and you can have many subscribers that subscribe to that channel, and they all receive messages from that channel. Right. Okay, now common fast data ingest techniques. First of all, pub/sub. This is the most popular among Redis users, and Redis users just love pub/sub because of its simplicity. And for those who are new to pub/sub, I'll show a quick demo of how to use pub/sub. Just see my screen here. So let me log in to Redis. So what I do here is I'll first subscribe to a channel. I'll call it my channel. So I'll do subscribe. It's a simple command, my channel. So what you see on the right of my screen is a Redis window, a Redis client, which I subscribed to my channel. And now I'll publish something to my channel. I'm publishing hello world to my channel, and as you see, my channel received, the one on the right side, the subscriber received the message. So similarly, you can have many subscribers that subscribe to my channel, and they all receive the data or messages published to my channel. So that is just an example. Okay, and I'll go forward so that I don't waste my time. So the next one here is the list data structure. And this is a very interesting data structure. Again, it's like a linked list, if you're familiar with computer programming. And you can add data to the right of the list or left of the list, and you can pull the data from the other end. So I'll again show an example here. So what I'll do is I'll do a left push. So I'll do L push. Or you can do R push if you want to push data from the right. It doesn't matter. So I'm pushing data to my list. My list is the name of my list. And I'll push hello world to my list. So right now, my list is a list which has only one message called hello world. And I can do hello world 2, which will be the second message in the list. And I can run a command lrange, which is list range, my list, from zeroth element, it is 0 based, to the last element. Last element is -1 or -1. So it shows all the elements in my list. The one that's at the end is hello world, and as you add more data, it goes on adding to the top of the list. So here now I don't want to subscribe to this. So what I can do is let me log in again, and I can do an rpop. So I'll do an rpop to my list. So that brings hello world, and if I do an lrange of my list, that would have removed hello world. So it is just you're adding data to the list and you're removing data from the other end. So I can do another rpop here that would have removed everything from the list, as you can see here. Now suppose I want to listen to the list, and if there is no data in the list at all, there is a blocking command. It is called brpop my list. This is a very interesting command again. And I can put a timeout, or I can put 0. 0 means wait forever. So I'm just waiting, I'm listening to this list and seeing if there is data that comes into this list. So once I do a push, L push to my list, brpop is a blocking call, and it will wait for the data and then pull the data. So you saw this here. So once I pushed data to my list, the blocking call waited for the data and it pulled that data. So that is the list. You add data to one side, to one of the ends, and you pull data from the other end. Okay, and I'll move on. The next example that I want to show today is a very interesting data structure. It's called sorted set. It is a set because it guarantees unique elements, and it is sorted based on some value. It could be based on alphabetical value, or you can have a timestamp that you can add so that you receive messages in the order they arrived, or you can just have a counter that keeps track of all the counts, and you can always pull data from the other end. Sorted set is a very interesting data structure because in the last two examples that you saw, once you pull the data, that data is gone from the data structure. In fact, in PubSub, if you don't subscribe to the channel, you don't receive data at all, and you should always be always be connected to that channel to receive data. Now, in case of sorted set, you don't lose data. It's always there for you, and you can always query data. You can go back in time and query whenever you want, and it follows a pull model. Okay, I'll show some examples once again. I'll show some commands. What I'll do here is I'll create a sorted set called my z set, and I'll do a z add. Z add is the command to add messages or add data into sorted set. I'll do my z set, and then what I'll do is I'll give a weight to my message. I'll just use a counter. I'll just use the weight 1 because this is the first message that arrived, and I'll call it hello world. And then I'll go on I'll add one more message, and I'll call it hello world 2. And now I can use the command zcard to get the cardinality of the set, or to know how many members are in my set. my Z set. So there are two elements in my set, and I can run commands Z range by score, my Z set, and here I can do from 0 to infinity, which is plus INF, and that shows all the messages. And if you want to pull all messages with scores, you can do with scores. So hello world has the score of 1, and hello world 2 has the score of 2. So you can always run this command to pull all messages from 0 to infinity. And now that you have read until 2, you can, and suppose I add one more to this, and let me call it hello world 3. What I can do is in the next pull, I can know my last pull, and I'll call 3 to infinity. So it's more like you manage the state. It becomes stateful. So your client becomes stateful. You need to know what was the last message you read and pull from there. Go on. So this is a quick introduction to the 3 data structures that we are going to show in our demo today. Fine. And we'll now go to the most interesting part of today's webinar, which is the demo. And the demo, let me give a small problem, an example to the problem description here. So the demo example is about the data from Twitter. So we are gathering data from Twitter, and we are getting all the tweets through our ingest system. And as the messages go through our ingest system, we are making some transformations, and we are collecting data, and we are adding some filters as the data flows. Now, there are 2 filters, as you see here. One at the top is English tweets filter. Now, what this does is it takes the JSON message and it looks for lang equals English, and it takes only those messages, and it pushes those messages down the pipe. So that's what it does. But as English messages go down the pipe, I have another listener that will take only English messages and get all the popular hashtags among English messages. So that's what's happening at the top right here. And in parallel, there is an influencer tweet filter. Again, this is part of the ingest system. The influencer tweet filter, it reads all messages, but it filters only those messages from users who have more than 10,000 followers. We just came up with this number, 10,000. So we're just assuming all the Twitter users with more than 10,000 users to be influencers, and towards end we are creating a catalog of all the influencers. This is a sample message format, sample JSON format, as you see here. And as you see, this language is English, and if language is not English, we just discard at the top. And then down here in the influencer filter, tweet filter, we are looking for followers count, and also we are collecting hashtags if the tweet happens to be an English tweet. Okay, that's the problem. And the demo setup, I'm using PubNub as a service provider for messages. You can use any service provider. I'm programming this whole thing in Java, and I'm using Eclipse as the IDE. And for Redis, I'm using Redis container on Docker. So I'm running this whole setup on my laptop. So I have Eclipse on my laptop and a Docker environment on my laptop itself. Okay. Now, the 3 ingest techniques we saw, PubSub, lists, and sorted sets, they have their own advantages and disadvantages. Now, PubSub, it's very easy. It's a decoupled setup. So the publisher doesn't know who the subscribers are, and subscribers, they don't need to know where their messages are coming from. They just subscribe to a channel. And it's good for a geographically distributed setup because it's all based on connections. Clients, they can always create a new connection, connect to your Redis database, and subscribe to a message, right? Now, there are some disadvantages with PubSub. It's not resilient to connection loss. So if you have a weak network, or if you lose connections, you lose messages, and the messages are not stored for you if you want to retrieve them later on. And also, each subscriber requires a connection. So if you're using a cloud provider for Redis, there are some cloud, just look at how many connections you can get on your cloud provider. So there may be a cap on number of connections you can get from your cloud provider. But PubSub, with that said, it's extremely easy, and it's a very, very popular feature, and we have many, many customers who use PubSub for data ingest. Now, lists, once again, they're very easy to use. They're resilient to connection loss. You add data to a list, and you lose connection, so what? The data is always there in the list. You can pull the data when you get the connection back. But the problem here is the producers and consumers, they're tightly coupled. So the producers, they need to know where the consumers are, and they need to manage a list, a separate list for each consumer, and push data to each list. And also, you have the problem of data duplication because you need to store the message for each consumer. Now, sorted sets. This is a very popular data structure for message ingest. Once again, it is not only resilient, it doesn't lose data at all. You store data forever, and you can always pull data from sorted set later on. But as you know, it consumes space, and Redis is an in-memory database. So and there are some workarounds to this on how you can get rid of data by putting a time to live. You can expire data, and also you can have data forever using Redis Flash, and you can make it cost effective, but it has its own pros and cons. Okay, so let me go to the first technique, which is fast ingest with PubSub. Now here, I'm getting all the data from the left. If you see, I have a class called ingest PubSub that receives all the data, and it publishes all the messages. It may receive thousands of messages every second, and it pushes all the data to a channel called all tweets. Now there are two tweet filters. One is called English tweet filter, and the other one is called influencer tweets filter. Now these two classes, Java classes or Java objects, they subscribe to this channel all tweets, and they get messages as they come in. Now the filters filter tweets, and they push those tweets further down the channel to their own channels, and finally the data goes down the stream. So that's how it works, and we already discussed some of the advantages of this. It's so easy to use, and it's a decoupled setup. So let me show you. There are some class diagrams here, and if you want to get the programs, you can go to GitHub, Redis Labs demo /ingest PubSub, and you can download the source code that I'm going to show right now. Okay, so let me go and open my Eclipse, and I have ingest PubSub. Let me go to the source, and here I have ingest PubSub.java. Okay, now this is the class that reads data from PubNub. So let me run this, and I'll show you what happens. Okay, as you see, there is a stream of data. You may see it or you may not see it on your screen, but the data is flowing, as you see. And as we go down the stream, our goal is to collect data and collect all the hashtags and all the influencers, right? So what I'll do here is, let me show that here. So I'll do a Z card on hashtag set. So this is a set that manages everything. So hashtag. I'll do first of all, I do a message count, get message count. So I have 1,024 messages. So as you see, the message count is growing. And then let me see if we have any influencers. So I have 40 influencers, so the list is growing. And if I do a Z-rev range by score, influencers, and then what I'll do is I'm doing a reverse range from infinity to 50,000. Let's say we want to see only influencers who are more than 50,000, who have more than 50,000 followers, and with scores. So these are all the influencers that we have collected so far, and I can do an get all of influencer CDN 37. So this is the catalog that we are preparing. So I have a follower count, and you can see all the data. So this is part of the ingest solution. So we are collecting so much data. Okay. So that is how we are working. Let's see how many messages we have collected so far. We have get count space here. So we have 1627 messages processed so quickly. So that is a quick example, and I recommend you to go to Redis Labs demo/ingest pubsub, and you can get all the source code. And it's a very simple solution. I have ingest pubsub that is getting all the data, and there is a publisher and subscriber, and I have a few classes that extend subscriber. So they're all subscribers, and publishers publish messages to a channel, and subscribers, they subscribe messages from a channel, and as they subscribe, they get messages, and they filter and push them down the stream. So it's a very simple solution. Okay, and the next one is fast data ingest with lists. So I'll do the same here. Let me close this, and I have a project called ingest list, and as you see here, the data is coming down the ingest stream, and all the messages are pushed to a list called all data. So I'm doing an L push or left push, and there is a listener called all tweets listener, and this does a BR pop or a blocking R pop. And it pops all the data, all the messages that come from the list. And this listener will push, or it allows other objects to register. So this is my design here. So I'm allowing objects to register for all tweets. And in this case, I'm having two objects, English tweets filter and influencer filter. So they are registering for messages, and they receive all the messages. And English tweets filter at the top, that will filter out and select only English messages, and it will push English messages down to the list. And finally, we are doing the same thing that we did in our previous example. Okay, so let me show here. So there's ingest stream, and before we go there, let me flush all the data. Let me clear this, and then I'll do a flush all. So that will flush everything. So I'll do a scan 0. And there's no data here. So my Redis is all empty right now. Okay, so let me start the stream. And I hope I don't have anything else here. So this is a list. Okay, now as you see, it's already collecting data from PubNub, and it is pushing everything down the stream. And if you see my design, all this goes to a list called all data. Now I have not started all tweets listener, so all the data is now just getting built up in all data. So let's see that, and you can do that with ln all data. Okay, let's see. So we have message count. It is building up, as you can see here. And then what I'll do here is, now I will start English. I'll start all tweets listener, and let's see what happens right now. So I'm listening all tweets here. Let me see. I'm not getting any message. Get message count. Getting message count here. And then let me start English tweets filter. So as the data comes in, I'm also starting all the English tweets. And also if I start influencer filter, let me start influencer filter. Z card. I have 91 influencers, recorded 93 influencers, as you see here. So they're all going up. So I have 102 influencers. So as the messages are coming down, they're being consumed, and they're going so fast. And if I do a Z reverence score as I did earlier, so these are all the influencers that we have collected so far, and so these are all the top influencers we have. So let me see and do a fetch get all. I'll take the last one here, EDD speaks. And you can see all the data getting cataloged. So this is a quick example of the fast data ingest with the list. So I'm pushing all data down the stream using list, and you can download the programs, and you can get the programs from GitHub and try it yourself. Okay, I'm stopping all of them. And the last, again, this is a design message list. I have a message list data structure, and there is a listener, and there is a message filter, and all the tweet listeners, they receive tweets, and then there are filters that filter data as the data goes down the stream. So this is the design, and you can go to Redis Labs demo /ingest list on github.com, and you can download the data, download the code. Okay, and the last one, the most interesting solution is the sorted sets. Now, sorted sets, it's a very popular way to get data, to ingest data. Now, first of all, it is resilient to connection loss, and you can always pull data. You can go back to the history, and you can fetch data whenever you want. And also, the producers and consumers, they are loosely coupled, because as a producer, you can just do a Z add to a sorted set, and you can have consumers pull data whenever they want and from wherever, as long as they have access to the sorted set. There is no coupling between producers and consumers. Once again, the design is extremely simple. I have ingest stream object that receives data, and then there is publisher and filter, and you can see there are filters, and they just receive data they just pull data from sorted set. Right? So let me do a quick demo here. I'll do a flush all. So once I do a flush all, it's all gone. I'll close all my programs from ingest list, and I'll open sorted set. So here, let me start ingest stream. So once again, it is collecting all data, and here I can do a Z code. So it is growing. So it's collecting all data, and I'm adding a counter. So as you see, it's just growing. But if I do a Z card on English tweets, it is 0. That's because I have not started any tweets filter. So let me start all the filters here. Once I start this, so you can see English tweets are growing too. And in this case, all data is growing. If I do a Z card, all data is growing. Now I have more than 1,000 messages collected already. And English tweets, this is growing. It is almost, it's 569. And let's look at Z card influencers. and there is nothing because I have not started influencer filter here. We have not started this. So once I start influencer filter, let's see how many influencers we have collected. We have collected 46 influencers. So I can do a Z rev range once again and see if there are any influencers with more than 50,000 followers here. Yep, we have a few. And I can do an H get all and look at how we have cataloged them. Okay, and this is the topmost that we have collected so far, and we can do this again. Okay, we're getting more and more influencers, and we have collected so far 73 influencers. And let's look at how many tweets we have collected. We have about 2,000 tweets, or almost 3,000 tweets. We'll reach that number very soon. So that is the demo. I can stop this. I can stop all the programs. Okay, I can stop all this. So right now, as you see, the data is always here. We have not deleted the data and sorted set. So now I can start the program again, and I can go back and I can fetch data whenever I need. So that is the advantage of sorted set. And there are ways you can use a timestamp as the index, as the score for a message. And if you use timestamp as a score, and if you catalog, then you can use sorted set as a time series database. So that is the third solution, and you can go to Redis Labs demo, and you can find ingest. I changed the name to ingest sorted set, so you can go and get ingest sorted set from Redis Labs demo. Right now, let's do a quick. Let's take a quick look at Redis Enterprise. Now, Redis Enterprise is the enterprise solution from Redis Labs. And if you're using Redis in production, for example, if you're using PubSub feature in Redis, and suppose you want failover. Now, Redis Enterprise offers failover. It's auto-fail. It offers automatic failover. So if you have all the publishers and subscribers subscribe to a few channels, and suppose your master server goes down, then what happens is the replica takes over, and your clients, they need to reconnect. And most of the clients, they do auto reconnect, and they all get messages, and it's totally seamless. And for the end user, you get an auto failover. And also, you can do clustering, and you can do linear scaling with Redis Enterprise. And most of all, we'll talk about Redis Flash in a second. If you're using time series database, or if you're using sorted set data structure for fast data ingest, then Flash will save a lot of money. And I will show some comparisons. And you can save data forever. And the data write happens with sub-millisecond latency, and you're not compromising on the performance. It's just that you're getting more volume to your data. All right. Now, this is what I was telling, Redis Flash. Now, Redis Flash is available only with Redis Enterprise. Now, Flash is used as a RAM extension. So what happens is, as you write data to the RAM, the first write happens to the RAM, and as data grows, and when there is an overflow, we push values to Flash. So there is a tiered approach to storing data, and this is going to save a lot of money. And let's see how much. Now, here is an example. Now, and in this example, the data set size is about 10 terabytes. And if you have Redis on RAM, and if you're using i3 instances on Amazon, it may cost about $1.5 million a year. It's about $1.5 million or $1.6 million. But if you're using Redis Flash for the same data set size, it costs about $300,000 on Amazon if you're using i3 instances. So that is the comparison of how much data you save by having Redis Enterprise Flash. Right. So now is the time for questions. If you have any questions, I can take the questions now. So let me start with the first question here. Is any security feature like authentication or authorization applicable with PubSub model? That's a good question. Now Redis has its own layer of security, and especially if you're using Redis Enterprise, you have SSL and other authentication mechanisms. So that is the authentication and authorization you get with Redis Enterprise. Now, if you're using open source Redis, keep in mind that if you have one node of open source Redis, and if you have multiple databases, they all share the channel. So it's a bit open. But with Redis Enterprise, each database has its own channel, set of channels, and they're all isolated, and you get a true multi-tenant environment with Redis Enterprise. Okay. Now let me look at the next question. Can PubSub model guarantee a message delivery? No. That's in one word. If I need to answer, no, it doesn't guarantee message delivery. But you can work around PubSub. You can make it stateful. You can add a layer on top of it yourself, and you can send an acknowledgement back to the publisher. You can have a solution. You can build a solution yourself where subscribers, they send an acknowledgement to publisher, and if publisher doesn't get a response, then it can resend the message. But the other alternate solution which we recommend is try other data structures. For example, try sorted set or try messages, where you get a guaranteed delivery of message. So we recommend you to look at other data structures like sorted set or list, if you ask me. Okay, let me look at the other question here. You said Redis Enterprise supports failover for PubSub. Is that totally transparent for the client? This is again a very good question. Yes, Redis Enterprise supports failover for PubSub. So the way it works is, if the master server goes down, the secondary server will take over in the backend, and it's totally transparent to the end user. But what happens in this process is all the clients, they lose connection to the server. But once again, most of the client libraries that are available today, they attempt to reconnect to the server. And if you're using Redis Enterprise, it is going to be the same DNS, it's going to be the same URL or FQDN that you need to reconnect with. And most clients, they do a reconnect, and within 2 or 3 seconds, you get back all the connections. So from a usage point of view, this is going to be seamless. It is totally seamless. But in this process, you may lose messages for 2 or 3 seconds. And if you can live with that, then that's really great. Okay. Are there any other questions? Okay, there's a question. Does PubSub support pipelining? Yeah, and for those who don't know pipelining is a very good feature in Redis. What you can do is you can send multiple commands to Redis database, and you don't need to wait for the response. You can send, let's say, 1,000 commands to Redis, and you can you can send it in a pipeline and wait for response only once, and you get response to all the 1,000 commands in an array. So that's how it works. And of course, Redis PubSub supports pipelining, and it applies only to the publisher and not to the subscriber, because subscriber is always listening to messages. There's no pipelining there at all. But publishing is okay with pipelining. Okay, the next question, what is the maximum limit on the number of connections subscribing to channels? There is no limit to the number of connections. Redis, it puts a soft limit of 10,000, but you can change that limit all the time. But keep in mind, the way Redis PubSub works is a publisher will publish a message, and Redis database will keep an output buffer. It keeps a message buffer for each client, and it flushes that buffer and it sends that message to each client in a sequential order. So if you have too many clients, then watch out. You may want to do some testing and make sure you're not taking a hit with performance. Okay, next question. If I use a sorted set, can I flush data on the sorted set on a daily basis? Yes, you could. In fact, there is a command called expire in Redis. It's a very interesting command. Let me show that to you. Let me do a demo. So here we have zcard all data. Let me see if I still have data. Yeah, of course, I have all the data. So what I can do is I can set an expiration. So right now, for the sake of the demo, I'll expire all data in 5 seconds, let's say. So I can do a zcard. I still have data. So if you wait for 5 seconds, that data will go away. So what we did here is I took out all the data from the sorted set, and you can put an expiration on a daily basis if you don't need the data, or you can put a week-long expiration time. It takes you need to put the number of seconds to expire, so you could do that. Okay. Well, last question. I think we have time for a couple of questions. Yeah, okay. Let me take a last question here. I use PubSub in my solution. I lose connections at times. Do you recommend to do anything? Okay. If you're losing connections, you need to look at logs and see why you're losing connections. And if you're losing connections, I'm assuming you're losing connections on the subscriber end. And if the subscriber is losing connection, just look at the log. It could be, it's possible that Redis is reaching the limit with the output buffer. And with that said, it gives me a very good transition to my next slide, which is about an advanced topic. If you go to redis.conf setting, there is a setting called client output buffer limit. And there are 3 types of output buffer limit or output buffers, and one of the output buffers is for PubSub. Now, you may want to manipulate this. You may want to increase the limit that you have on PubSub, but if you increase the limit, keep in mind it may hurt your performance. And what this means here is, now Redis maintains an output buffer for every client or every subscriber. Now, if the output buffer reaches 32 MB, now with this setting, with this default setting, Redis will disconnect that subscriber. Now, this is possible if the subscriber is consuming data at a slower pace. So if the output buffer reaches 32 MB, it disconnects that subscriber. Or the other reason is if the output buffer is consistently above 8 MB with this setting for 60 seconds, it will disconnect that subscriber. So that is the one. I'm told there is only one question. Is there one question? How can we achieve topic-based routing with sorted set ingest? Oh, that's a very good question. How can you have a topic-based routing? Now, you need to. You can see my solution here. I'm doing that in a couple of ways. What you have to do is you can do a listener that will pull data from sorted set, and you can have other objects that will subscribe to that listener. I have solved this exact problem in my solution, so you can go to GitHub and look at the solution. But with that said, very soon Redis is going to introduce Redis stream data structure. It is not ready yet, but that is one of the data structures in the roadmap. But as soon as you have that data structure, you should be able to do this automatically. Right. So with that said, we come to the end of questions. I don't think we have time for any more questions. Thank you so much. Thanks for attending this webinar. And if you have any questions, feel free to send me an email, or if you have any generic question, you can send an email to expert@Redis Labs. And now I'll hand over the webinar back to Sharon. Sharon.
Hey, thanks, Roshan. Great topic. Your demo was outstanding. I know that during your demo, we got quite a flood of questions. There were some that we didn't get to, but we will answer them individually. So great topic with a lot of interest. So we're at the end of our broadcast, and thank you for joining us today. An email will be sent with a link to the recording of today's broadcast. Hey, join us next week, Wednesday, July 26th at 11 a.m. Pacific for our broadcast with Pivotal. That broadcast's title is Deliver Performant and Highly Available User Session Stores for Cloud Native Apps. Visit redislabs.com/webinar and register today as space is limited. Thank you again, and bye for now.